Okay, so let's get right back into it with the second argument in this philosophy of science section. So we're going from talking about an argument by Hilary Putnam to an argument by Karl Popper. Karl Popper was also a 20th century philosopher. He wrote primarily on science and politics, and the argument of his that we're going to look at is this so-called demarcation argument. And he here is arguing or trying to give us a way to distinguish science from non-science, right? And if you take any sort of philosophy of science class, or if you take science in the modern world here, you will most likely talk about the demarcation argument, or at least you may not refer to it as such, but you will talk about how are we supposed to distinguish from science and pseudoscience and just non-science. So that's what this argument has to do with. So once again, we have a very short argument. Some of the arguments that we'll get to later in the term are incredibly long. There's not really any rhyme or reason for why one argument is longer than the other. It's just a matter of how complex the issue is, or how complex the author of the argument thinks the issue is, that sort of thing. So once again, we have two premises and a conclusion. So here we go. Premise 1. If a theory is scientific, then it makes claims or predictions that could be shown to be false. Premise 2. A theory warrants only confirmation and ignores falsifying evidence. A theory that warrants only confirmation and ignores falsifying evidence cannot be shown to be false. Conclusion 1. A theory that can only be confirmed and not falsified is not scientific but pseudoscientific. All right, so let's go through this bit by bit. First premise. If a theory is scientific, then it makes claims or predictions that could be shown to be false. So the important word here is could, right? So this is what's called the subjunctive, right? Were this true, then this other thing would happen. It could be so. Right? It's talking about a counterfactual. So counterfactual statements are very important in, well, I mean, pretty much reasoning in general, but they're referred to as such, and a lot of a lot of theoretical weight is put on them in philosophy. Counterfactual, just as sort of the name notes, is a statement that is counter to facts. That is, which isn't true, but sort of could be true. So if a scientific theory could, in principle, be shown to be false, then, well, a theory, if it could, in principle, be shown to be false, well, that's a reason to suspect that it may be scientific. So, importantly, it does not mean that every scientific claim is actually false, or can actually be shown to be false, right? What does that mean, can actually be shown to be false? Well, that would just mean to say that every scientific claim is actually false. So it may be that we never will show a particular scientific claim to be false. It will never happen. But it has to be possible that it could happen. That's what premise 1 talks about. What does it mean for a theory to be in principle falsifiable? Well, that means you can kind of imagine an observation. You can imagine a set of data. You can imagine some state of affairs, something that somebody would tell you, which would make you reject that statement. Okay? So an example, water always boils at 100 degrees Celsius at 1 atmosphere of pressure. That's a scientific statement because if someone showed you a sample of water, let's say deionized water to get rid of the possibility of salt changing the boiling point. If they boiled some sample of deionized water at sea level, that's what 1 atmosphere of pressure means, and it was at 102 degrees, well, you would have a falsification of the statement, all water at sea level boils at 100 degrees Celsius. Okay? Now, of course, that doesn't happen. at least assuming that you're actually at 1 atmosphere of pressure, that is sea level, assuming that the water doesn't have salt or any other sorts of impurities in it, no one has yet provided that kind of counter evidence, that kind of counter observation. But they could. You can imagine what that would be like. That's all it means for something to be, in principle, falsifiable. And hopefully that's relatively clear. 2. A theory that warrants only confirmation and ignores falsifying evidence cannot be shown to be false. So here we're trying to think of an example of something where you can't imagine what type of observation, what kind of statement, what kind of evidence, what kind of state of affairs. You can't imagine anything that would prove a particular statement to be false. That's what it is for a statement to be non-falsifiable, to be only confirmable. So I provide an example here. All actions are motivated by selfish desire. When an action appears to be selfless, there is actually a hidden selfish desire which actually motivates them. Okay? So here it ignores falsifying evidence, and it doesn't ignore it, it sort of tweaks it, right? Every bit of putatively falsifying evidence, that is, every situation which someone brings up and says, well, what if somebody, so we're talking about egoism here, about selfish desire. The egoist says, everyone's actions are always motivated by selfish desire. Someone goes, well, what about when someone sacrifices their life in order to save somebody else? That's obviously not selfish. The egoist says, well, there's a hidden selfish desire which is actually motivating. That is, they want to sort of go down in history as a hero. They don't want to have to live with this sort of survivor guilt, so that's why they sacrificed their life. They didn't really care about the other person. They were still just caring about themselves. The egoist will try and give that kind of explanation every time you dream up a sort of imaginary counterexample to their thesis, or even if you point out actual instances which look like they should falsify the thesis of egoism. The egoist will go, no, that doesn't actually do it. Okay? The idea is anything that is like that, which you can't imagine a situation that would falsify it, or which ignores all putatively falsifying situations, that is not a scientific thesis. I mean, that's what the conclusion is about to tell us next. So importantly, articles of faith are like this. So you can imagine, and perhaps not everyone is like this, some people might say, well, look, I believe in a divine being, and there is nothing which could dissuade me of that. There is no evidence you could give me, there's no argument you could give me, nothing could change my view on this. Well, the idea is that that kind of statement is not a scientific statement, because it does not admit of the possibility of being falsified. So hopefully that's, again, relatively clear. And so, as I said, a theory that can only be confirmed and cannot be falsified is not scientific, but pseudoscientific, or we could just say non-scientific. So here, instead of having a modus ponens argument, which we've become familiar with from our past couple arguments, we have what's called a modus tollens argument. These are pieces of Latin jargon. Modus ponens means the mode of placement, or the mode of putting, something like that. Modus tollens means literally the mode of strength, something like that. It doesn't really matter why they're called that. So we still start with this if P then Q, but instead of, in the second step, saying, hey look, P, and then concluding Q, what we do is we say, hey look, not Q. And therefore we conclude, well then also not P. And so this is how Popper's argument sort of gets broken down in this schema here. One is the if P then Q statement. If a theory is scientific, then it makes claims or predictions that could be shown to be false. So again, this first part is if, oops, no, don't do that. What have I done? Go back. There we go. If P, that's this part here, okay, then Q, right? So that's this second part here. And here, this says not Q. Not Q meaning it says that Q is false, okay? If a theory is scientific, then it makes claims or predictions that could be shown to be false. 2 says this theory or some theory cannot be shown to be false, right? Its claims and predictions don't admit of being falsified, right? So that's why it's not Q, right? That is to say, it is the negation of Q, right? So sometimes you see this little turnstile symbol or the tilde in front of a letter, in front of a statement. That means it's not the case. So it is not the case that a theory warrants, that a theory makes claims or predictions that can be shown to be false. So whenever a particular theory is such that it doesn't make claims and predictions that could be shown to be false, right? So Q, not Q. Then that theory can only be confirmed and not falsified and is therefore not scientific. I've sort of messed up here. This should say not P rather than not Q. Let me fix that. Stop annotating. So I'll have to go back and fix this and upload this fix here. So if a theory is scientific, then that theory makes claims or predictions that can be shown to be false. Some particular theory does not make claims or predictions that could be shown to be false. Therefore, that theory is not scientific. Okay? So the way that the argument is worded in the book is a little bit confusing. I mentioned in the first week that oftentimes these arguments will sound really repetitive. You can see here it would have been better if they just repeated this here, right? So I'll show you how this would have worked. This, instead of saying a theory that warrants only confirmation and ignores falsifying evidence cannot be shown to be false, what it would have been better for them to say is a theory does not make claims or predictions that could be shown to be false, right? Why is this a more straightforward way of stating the argument? Well, because this here, 2, is just the same as the second part of 1 here, except it says not make instead of does make. So hopefully that's clear to everyone how Q and not Q are related to each other. Let me undo all that now. There. Okay. So that's how modus tollens works, and that's how Popper's argument is an example of modus tollens. So here's I say joke, I say famous joke. It's not clear that it's funny, and none of you would have heard it before, but it's a saying amongst philosophers. One person's modus ponens is another person's modus tollens. I mean, it's really funny, So what does that mean? Well, here's another example of an argument. Imagine a particular claim. And this is a claim that we'll look at again later in a separate lecture. If we know that we have hands, then we know that we are not brains in vats. So now we have 2 different people. Leo says, hey, we do know that we have hands, P. Therefore, we know that we are not brains in vats. Okay? So Leo is engaged in modus ponens. He's taking this if P then Q statement. He's saying, well, guess what? P. And therefore, he is concluding Q. Marion, on the other hand, says, well, we don't know that we are brains in vats. Excuse me, we don't know that we are not brains in vats. Therefore, we don't know that we have hands. Marion here is engaging in modus tollens. So she says this if she sees this if P then Q, and she says, well, not Q, so not P. There is not really anything immediately available to us to settle this dispute, right? So whether or not you should engage in modus ponens or modus tollens is sort of a matter of demonstrating either that P is true or that Q is not true. So that's why the second step in this sort of argument, after an if P then Q, the second premise is incredibly important and is what sort of bears all the weight of the argument. So if a theory is scientific, then it makes claims or predictions that could be shown to be false. If we replace this with a theory does make claims or predictions that could be shown to be false, the conclusion would instead be that theory is scientific. And so we could do that for Popper's argument as well. We could emphasize the sort of positive aspect rather than the negative one, and we'd be saying kind of the same thing, more or less the same thing. Popper has chosen the negative one because he's trying to point out in particular what things are not science, what things are pseudo-scientific, and then go from there. So don't worry too much about this. I'm just explaining the relationship between two forms of argument here. Okay, so let's think about Popper's argument. He says that if a theory is to be scientific, then it must make predictions which could be shown to be false. This is why his view was called the falsificationist view of science, right? He says what science does is put forward claims and then just waits to see if they get falsified, right? As long as a claim isn't falsified, then we say, well, it's probably true. That's basically how it works. This was meant to replace the so-called verificationist view, right? So verificationism, which preceded Popper's view earlier in the 20th century, in the late 19th century, the idea there was, well, what scientific statements are, what scientific truth is a statement that's put forward and then is conclusively demonstrated to be true by observational statements, right? So we say water boils at 100 degrees Celsius, and then we go and we heat a bunch of different samples of water to 100 degrees Celsius, and we say, aha, that statement is verified. Well, the problem is a statement is never fully verified until every possible instance of that statement has successfully carried through. That is, we have to forever and always boil each sample of water to 100 degrees Celsius. Only when all water is constantly boiling, when all water is constantly heated to 100 degrees Celsius and therefore constantly boiling, will we have thorough, total verification of that statement. Now, of course, that's incredibly implausible. We can't just boil all water forever. That's not plausible, and having to wait on that kind of evidence in order to say that a statement is scientifically true, scientifically valid, is just not going to work. So Popper says instead we treat a scientific statement as true until we have evidence that demonstrates that it is not true. So that's the difference between falsificationism and verificationism. So what's the problem? Well, falsificationism might be better than verificationism for a variety of reasons, but it still doesn't provide us, as I say here, a distinctive characterization of science. So that is, there may be some types of statements which could be falsified, right? Which we can imagine a situation in which they would be demonstrated to be false, but we still don't want to necessarily call that statement scientific. Okay. So there are other things that need to be true for something to count as science. That is why the demarcation argument is formulated as a modus tollens. It tells us only when something isn't science, right? So it says, well, if this theory's claims cannot be falsified, then it isn't science. It doesn't tell us that if a theory's claims can be falsified, possibly, then it automatically is science, right? It doesn't tell us that. So where are we? We've done these two arguments now. Putnam and Popper's arguments are meant to show us that scientific investigation does sort of progress. It does get us closer to some sort of accurate picture of the way things actually work. And that scientific statements can be distinguished in some way from pseudoscience and non-science, right? This is supposed to show us a way of rebutting the kind of thing that Nietzsche said, right? Nietzsche says, well, there's not really any difference in amount of rationality between a theistic view and a scientific view. Putnam and Popper, in arguments like theirs, are saying, well, not so fast. There definitely is. Religious statements are going to be supposed by Popper, for instance, to not admit a falsification, right? So various religious beliefs are sort of dogmas. You have to believe them in order to be a member of the religion. You don't believe them because there's good evidence for them. You believe them because you've been told to, or something like that. That's the kind of thing that Popper's going to say. So they're not scientific. Scientific arguments could, again, in principle, be falsified. And that alone makes them more rational because they are sensitive to changes in the world. They are sensitive to evidence. And also, our scientific theories let us sort of do stuff, build stuff, and if they weren't well-founded, then we wouldn't be able to do stuff and build stuff with them. So here are some reasons, the beginnings of a way of saying, well, Nietzsche's just wrong, right? Now, this doesn't tell us that naturalism and scientific viewpoints are without fault, that they always get everything right, that they are perfectly rational, but it does tell us, or it purports to tell us, that they are more rational than religious views and supernaturalism. So that's where we stand at the moment. Now, of course, moving into the thing that you're going to address in the reading sequence, we'll see how well this kind of scientific realist argument stands up to what Thomas Kuhn argues. So Kuhn is going to put forward his very famous incommensurability arguments, and I want you to analyze and criticize them in your active reading, in your group, and in your individual summaries, like I have analyzed and criticized the two arguments from Putnam and Popper in this lecture. So as usual, this reading, which is chapter 90 in the textbook, section 90, whatever, will be the basis for your week 2 active reading assignment, group discussion, and individual summary. And one reason I want you to, at least this week, definitely take a look at the recap of week 1 is that I'm going to talk about the group discussions and talk about how I want you to sort of, do a bit more, change the dynamic in your group discussions a little bit on the basis of looking at sort of what went on in week 1. So I will write a bit of news on the front page of the course to talk about how I want you to sort of change the group discussions a bit going forward, but I will also talk about it in the recap video for week 1. The recap video, of course, will be under week 2. Hopefully this will all become familiar within the first 3 weeks, where everything's going to go each week, so on and so forth. But as usual, if you have any questions, you can, of course, ask me. So that's all. This is the second part, the end of the second part of the lectures for week 2. In the second part, we looked at Popper's argument. In the first part, which is a separate video, we looked at Putnam's argument. And then remember that at least in week 2, there will be 2 other little video snippets, one about the icebreaker discussions and what is philosophy, and then another which is a recap of week 1. So make sure to take a look at all of those. Thanks.